Hello everyone, my name is Ranjit Kumar. I'm working as assistant professor in the Department of Computer Science and Artificial Intelligence, SR University, Warangal. In this session, I would like to explain the functionality of router in the computer networks and its simulation using packet tracer. So router is one network connecting device. So in my earlier video, I demonstrated the connecting devices like hub and switch. So similar to those devices, so router is another connecting device, so which is going to connect different networks, especially these local area networks together. So without these routers, so connecting to the internet or outside network or outside world is impossible. So that's why these local area networks will be connected to connected to each other or connected to the internet by using this router. For example, you let us take this is a network. So in this network, this is one local area network, and this local area network, in this network, these two systems are connected by using the switch or hub. And similarly, this is another local area network where two systems are connected by using a switch or hub. So these two are the two local area networks. So when these local networks want to connect with the internet, so then we must use this router, and this router is going to connect these two local area networks to the internet. So that is the reason why to connect local area networks to the internet we use this router. So if you don't want to connect to the internet, so then no need to use this router. Only with the help of the switch or hub, so we can make the network, but those networks are local networks. And this router will operate at layer 3 of the OSI model. So this is the OSI model. This contains 7 layers. So each layer is a collection of related network functions. Whenever a data sent from one system to another system over the network, so these layers are going to involve. So each layer represents a set of related functions. So earlier in my previous video, I demonstrated two networking devices, so which are hub and switch, and that hub will operate at the layer physical layer, and switch operates at a data link layer. So similar to that here, the router is one layer, one network connecting device, so that will operate at the layer 3, that is network layer. And this router will provide the best path from the source to the destination, so over which data can be sent. For example, this system want to send a message to this system. So from this system to this system, what is the best path? So that will be provided by using this router, over which data can be exchanged between two systems on the network. So now as far as this router is concerned, whenever we are talking about the router, definitely we have to know the IP address, and we have to use the IP address. So for example, in the when we are working on the LAN, so mostly that LAN is going to work on the physical address or MAC address. But whenever these LANs are connected to the internet, so then we must use IP address. So these IP addresses are used to uniquely identify the system on the internet or device on the internet. So IP addresses, these have two versions, IPv4 and IPv6, but most commonly used IP address is IPv4, and that IPv4 contains four parts. We can call this as octet: first octet, second octet, third one, and fourth one. Or we can call this each part as byte: first byte, second byte, third byte, and fourth byte. So this IPv4 contains four parts, and each part is called as a octet. And in this octet, we write some number. In this octet, we write some number. And here we write, and here we write some numbers. Four different numbers. So we write in order to represent one IP address. And each number or each octet is separated by dot. And whenever we are writing some number in this IP address, so that number should be in the range 0 to 255. So whatever the number we write in the first octet or second octet or third octet or fourth octet. So in these individual parts, whenever we are writing a number, so that number should be in the range 0 to 255. And these IP addresses, these each octet can be represented using decimal number or binary number. But for our convenience here, I am considering only decimal number example. So IP addressing IPv4 or IPv6 address, it is a vast topic. But here I would like to present only overview of the IP address because we are using router. I am not going to explain this IP address in detail, just I would like to present only overview for the purpose of this router. Right? So these IP addresses are classified into 5 classes: class A, class B, class C, class D, and class E. So mostly we use up to class C only. So this class D is the multicast address and class E is the reserved address. But we use only first 3 classes to address any system or network. So look at this class A address. So in this class A address, total 4 bytes are there or 4 octets are there. So this is starting range of class A and this is ending range of the class A. Right? So in these 4 octets, the first octet represents network address or network ID. Remaining 3 parts represents, means 3 octets represents host address or host ID. Right? So host ID means the systems, means these many number of systems can be addressed. These many means here, this is 8 bits, 8 bits, 8 bits. So total 24 bits, 2 power 24 systems can be addressed in one network. Okay. So this first byte represents network address, remaining 3 bytes represents host address. But how to identify a particular IP address comes under class A address or class B or class C? So that can be identified by based on the first byte, the number we are writing in the first byte or first octet. So let us take one example here. So 10 dot, whenever we are writing IP address, we must write 4 parts, means 4 octets, and each one should be separated by dot. So 10 dot 10 dot 10 dot 1. So if you observe this first value, this is 10. So 10 is in the range 0 to 127. So while writing IP address, the first byte number in the range 0 to 127, so then we can decide this as class A address. So once it is a class A address, in the class A address, first byte represents a network address and remaining 3 bytes represents a host address. So similarly, coming to the class B, so class B range from 128 to 191. So let us see some address as an example: 130.20.10.2. So here if you take this first octet, the first octet represents 130. So 130 is in the range 128 to 191. So that's why this address can be identified as a class B address. So if it is class B, that means first 2 bytes, means 2 octets represents network address, last 2 octets represents a host address. So here you can find here these first 2 parts are colored as yellow color to represent the network address. So remaining 2 bytes represents a host address. So while calling this IP address individual parts, so you can call it as a byte or octet. Now coming to class C, this is the class C range, but here you look at this color, yellow color. First 3 parts are colored in yellow color. That means first 3 octets represents network address, last octet represents host address. So let us take one example. Here is the example: 200.20.10.4. So this 200 means it is in the range 192 to 223. So that means this falls under class C address. So since it is a class C address, the first 3 bytes represents network address, and the last byte represents a host address. So in this way, whenever we are using the router, so we must assign IP address to each and every system that is connected. So in my previous video, while discussing hub and switch, I showed you how to assign IP address. So in the same way, here we assign the IP address. But whenever we are assigning IP addresses to different network devices, so sometimes there is a chance to get the error. That's why we have to follow the different classes in order to address those different LAN systems. Okay. So now this is the just overview. This is a vast topic overview of the IP address. So now I would like to show you how to simulate this router by using the packet tracer. So now I will show you. In the last video, I showed you how to download packet tracer and how to open. So here I am directly opening that packet tracer and I will simulate this router. So I already opened packet tracer. So this is already taken one. Just I am deleting this. So deleting. So now in the same way you take two. So here you can find below network devices and host. So here you can find a network at first one represents network devices. So in this second one represents end systems. You select this and go to this system. You take laptop as that is PC. So you take two PCs for one side and two PCs for another side because here we are constructing two LANs. So that's why one for one LAN, two systems, second LAN are two other systems. So LAN means first these are connected using a switch or hub. So let us take this switch. You take the switch, you go to the network devices. Here you can find below, here you can find switch, and from these switch you select the first one and you keep the switch here. Okay. So now this represents one local area network. This is another local area network, and these two are connected by using router. So in order to connect the router, again you go to the network devices, and here you can find first device. It represents routers. You select, click that, and from here you select the first router, and you click on this working area. So now in order to connect, earlier I showed you directly select this orange color symbol and automatically it will connect. So but here to which port that device has been connected, that we should remember. So that's why instead of directly first you select this connection. So this is PC, this is network connecting device. So these two devices are different. This is end system, this is connecting system. So different systems are connected by using this straight through cable. Here you can find straight line. You select the straight line, click on the PC one. Here you can find fast Ethernet 0. Select that and click on the switch. Here for the switch, different all ports are there. Here you click this first one, fast Ethernet 0 by 1. So you can connect to any of these port, but you should remember that. So that's why you start from the beginning. It is easy to remember. Okay. So next, similarly, you take this one and click on the second system, Ethernet 0, and here fast Ethernet 0 by 2. Already 0 by 1 connected to the first system, and this is 0 by 2 connected to the second system. So while making connection, at either end we should get the green color symbols, but this is a switch intelligent device. It learns the physical address of devices. That's why it takes some time to turn these symbols into green color that I explained in the previous video. So, similarly, you make the connection to this side also, Ethernet 0, and this is 0 by 1, and this is also Ethernet 0, So this is 0 by 2. Now LAN connection is over. So now make the connection between this switch and router. So switch and router, these two are connecting devices, not end devices. So this comes under same category. That's why you select the crossover cable. Your dotted line is there. This is crossover cable. You select the crossover cable. Click on the switch, and below gigabit Ethernet 0 by 1 is there. You select that, and router and gigabit Ethernet 0 by 0 over. Now again you select the crossover cable, and this side gigabit Ethernet 0 by 1, and this is 0 by 1. So this side from the router, this side we are connecting to 0 by 1. This left side connecting to the 0 by 0. Okay. So now here we won't get red color. We have to make this turn on. So then it will be, this red color becomes green color. So before going further, first we have to set the IP addresses. So in order to set IP addresses, so first you take this note for our convenience, because which system is given the which address, in order to know that you take a note here. So from this top you can select this one and click here. So for this I am setting 10.10.10.1. Okay, this address. So 10 dot I am using 10 means this is class A address. So similarly for this 10.10.10.2. Right? So this is class again same class A address for the PC4. Right? So now coming to here, this part, this local area network connected to this one, because whatever the message we are sending from this network, that will go through this port. So for this port means this gigabit Ethernet 0 by 0. For that port, the switch has been connected. So that becomes the default gateway. For all these systems, that is the default gateway. So let us take default gateway. So 10.10.10.3. Now for all left side, we have taken class A address, starts with 10. Now coming to this side, let us take class C address 200.10.10.1. Now this is 200.10.10.2. Now this is right side LAN. This is connected to the 0 by 1 port of this router. Right? So for this router, 0 by 1 is the default gateway for this right side LAN. So that's why for this right side LAN, default gateway 200 dot so 10 dot 10.3. This left side I have given 200.10.10. So 3. Just wait a minute. Just I move this one. Okay, this is right side. So this is a left side. Now this is for our purpose. Just I made a note, but actually IP addresses have not been assigned. Now I will assign one by one. So for this total left side systems, this is the default gateway 10.10.3. Okay. So now you click this first PC, left side PC5, and go to desktop IP configuration. And here you set the IP address. What is the IP address? So 10.10.10.1. Now click on the, automatically you get the subnet mask and the default gateway. For this default gateway, for all left side LAN systems, default gateway is 10.10.10.3 we have taken. Now write in the default gateway and close this. Similarly for the second system also. desktop IP configuration. This IP address is 10.10.10.2. Now same default gateway is the same for all systems uh, connected to the left side LAN. So that is 10.10.3. So now IP address for these two systems assigned. Now you click this router, and router go to the configuration. Router, you click on the configuration on top of this, and left side connected to the gigabit Ethernet 0 by 0 by 0. So you select that 0 by 0 first one, and here on the top right corner you can find on button. You click this checkbox. Now you are turning on this router. Now here IPv4 is there. IPv4 means that is the default gateway address to the left side LAN. Left side LAN means to this LAN. That default gateway is 10.10.3. And you click the subnet mask, automatically you can get the subnet mask. You don't worry, leave it and close this. Now this gradually becomes green color. Now this side still it is red color. We have not assigned. So now left side assignment, IP address assignment is over. Now coming to the right side, for this right side network, this is the default gateway. Now for first you set the IP address for this PC. Select that, go to the desktop and IP configuration, and here you write the IP address. What is the IP address? Wait a minute. What is the IP address? Two 200.10.10.1. So here you write 200.10.10.1. Here you get default automatically. And what is the default gateway address for the right side LAN? So 200.10.10.3. Now close this. This is 200.10.10.3 is the default gateway for systems connected to the right side LAN. Now similarly, you select the second system, second desktop IP configuration, and 200.10.10.2. Now default gateway 200.10.10.3. Okay. So default gateway is same default gateway for all systems connected to the right side LAN. So now you click this router, and right side LAN connected to the 0 by 1. That's why you select here under interfaces, you select the 0 by 1. And on the right top corner button is there, on button. So you click this checkbox. Now our right side this 0 by 1 interface will be turned on, and the IP address IPv4, you select this field IPv4 and enter the default gateway for the right side LAN, that is 200.10.10.3. Now this is subnet mask, automatically will be assigned. So now close this. So now look at this, all symbols along these communication links turned into green color. So now you simulate. For the simulation, on top of this window here, you can find the PDU, protocol data unit. You select the PDU, select the any source system and any destination system. So source system from this LAN, destination system from this LAN. So here you can take not only two systems, you can take more than two systems. For simplicity, I have taken only two systems. So now from this LAN, I'm selecting this as a first one as a source system. You click this source system, and on the second LAN right side, I'm selecting this as a destination system. Okay. So just click on the source system and destination system, and below this screen right side or below corner here you can find simulation. You click the simulation, And here you can find play button. Just you click on this play. So look at that. That packet is traveling from source to the destination. So this is wrong. That's why you are getting in red color. So now you can see this from the source, that data packet traveled to the destination. So here you are getting cross symbol, means this is not our destination. So this is only our destination. So in this way you can simulate that router by connecting two different LANs. So hope this is informative for you, and thank you for watching. Thank you very much.